Right, we're going to finish up with section 8.1, part 1. This is the beginning of the last full chapter that's dedicated to just trig. Okay, so chapters 6, 7, and 8 were all trig. Once we finish 8, then we're pretty much done with that part of the class. So we've studied solving right triangles before, where you figure out all the sides and all the angles. You can use Pythagorean theorem. You can use the SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, and so on. But if none of the angles in your triangle are 90 degrees, then that means you do not have a hypotenuse, because the hypotenuse is across from the 90. That's an oblique triangle. In an oblique triangle, Pythagorean theorem doesn't apply, because that's only for right angles. And opposite over hypotenuse, adjacent over hypotenuse, none of that works either, because you do not have a hypotenuse in an oblique triangle. There's a couple different ways you can think of an oblique triangle. For the purpose of drawing a diagram, I usually always draw it this way, on the right. But if you think of an acute triangle, an example would be an equilateral. All the angles are 60. An obtuse triangle, you got one angle that's bigger than 90. But you can only have one angle bigger than 90. You can't have two. So when we set up a diagram for drawing these kinds of triangles, we don't have the right angle anymore. So we need to give a name to that angle. It's not just called the right angle. So we already had names for all the sides. What did we use for the sides?
A, B, and H. No, the X, Y, A, B, and C.
A, B, and C. And what about the angle across from A? Alpha. Across from B? Beta. And now we're going to have the one across from C. That's gamma. So the labeling is pretty similar to what we've done before. We just have one new label. It doesn't matter which way you rotate or flip your triangle. If you want to draw it in different ways, you can. If you draw it that way, that's fine. It's just wherever you put A, make sure alpha is opposite, B, beta is opposite, and then C is opposite gamma. There's no rule about which side needs to be the longest side in this case. Could be A, B, or C.
Yes, this.
So there's...
Oh, no.
What?
So you're doing
No.
Okay.
So depending on the information that you're given is going to control how we solve it. Okay? There's two laws that we need to learn to solve triangles that don't have a 90-degree angle. One of them is the law of sines. The other one is the law of cosines. Law of sines applies to three different kinds of problems. The first two types of problems it applies to are when you know two angles and a side. And let me give you, do I have diagrams of them? No, I'll draw a diagram. Two angles and a side would look like this. The ASA is just referring to the information that you are given and where it is. So let's say this was 20, this was 5, and this was 100. This is angle side angle, because you know two angles, and specifically the side that you know is between the angles. That's why the S is between the A's. Side angle, a little bit different. So you know two angles. So that's 30. Say that's 110. And this time, the side that you know is not the one between the two angles. So that could be either this one up here or the one on the bottom. But you have an angle, and then a side. But the side is not the one that's between the two angles. And the third case is side-side angle. And that one would look like this. Side, side. And then it's important that the angle is not between the two S's. So this angle is not the one that you could know. That's different. Okay, we're not going to look at that one today. So let's say you knew this one. That's an example of side-side angle. Two sides and an angle that's not between them, or they could have given you the angle at the top. As far as the way you write the kind of triangle, sometimes you see it written the other way. This is the same as AAS. That's okay. This one, we're going to leave it in that order. It's better that way. So leave it as side-side.
Oh.
Now, no matter what type of triangle you have, the angle, side angle, or side angle, those three problems all use the law of sines. And if you wonder what other type of triangle is there, well, there's side, SSS, and then there's SAS, side, angle, side. Angle wouldn't be one of them, because if I just told you I'm thinking of a triangle and all the angles are 60, 60, and 60, tell me the size of the sides. It could be anything. So in order to solve any problem, you always have to know at least one side, sometimes two, or in the case we'll look at when we do law of cosines, all three, side.
You always need three pieces.
You always need three pieces of information, and a minimum of one of them has to be a side.
Okay. Alright, what if you have three sides? Can you solve it?
Yes.
No. Yeah, never mind.
Not with this. But the law of sines is used for these three types. Right, so we're going to take a look at what the law of sines is, and then I'll show you how to use it in a problem. Okay, so to figure out what the law of sines is, I'm going to start with that triangle. And we don't know yet how to work with triangles that are oblique, but we do know how to work with what kind of triangle? Right triangles, yeah. So what I'm going to do is I'm just going to split this into two triangles.
Oh,
Like
I remember this.
that line doesn't necessarily cut the bottom side in two equal pieces. Here it definitely doesn't. But it's just a line that comes straight down. Now I need to label some of the sides that I'm going to use. Okay, I'm going to label this side A. And remember, the angle across from A is alpha. Those are 90s. I'm going to make this side B. And the angle across from B? Theta. I don't need gamma and C because I'm not going to use them, so I'm not going to label them. But I also need to label this line I just drew. How could we label like what that is? What is it? Yeah, we could call it C.
Just X.
But what is it?
It's just a side or an intersection.
Well, it's a special line that it's not just a random line in this big triangle. This has a name.
The height.
It's the height,
Oh.
or it's an altitude. I wouldn't call it A for altitude because you already used that. But you could call it H for height. Just don't confuse that with hypotenuse. But it's the height of the triangle. All right, now we're going to look at the left triangle first, then we'll look at the right. I want to write down a trig function that's going to use this angle, this side, and that side. What's the position of side H relative to alpha? That's opposite. And what about B? Hypotenuse. Opposite and hypotenuse. What trig function has those two? Sine. So the sine of my angle. And what would go on the other side?
H over B.
H over B. Now I want to get a formula for H. So how would I get H by itself here? Multiply both sides by B. And there you go. That's a formula for the height. You just have to take the sine of the angle and multiply it by the hypotenuse. And that's the height. I'm going to do the same thing again. But this time, I'm going to look at the triangle that's on the right, not the one that's on the left. Okay, so I did that one. I want to use this angle, this side, and that side. What trig function would involve H and A?
Sine.
A sine again.
That was it. B sine of H or B sine of alpha equals H.
Uh,
The other one.
Wouldn't it be cosine? Because
cosine would be
yeah,
if you knew this.
yeah.
What's the sine of beta equal to here?
H over A.
H over A. So what is H?
A sine beta.
A sine beta. So there is another formula that calculates the height of that triangle. Same height as the first one. So what do you know about box 1 and box 2? They're equal. So B sine alpha equals A sine beta. Now what I'd like to do is make sure the B is over with the beta, and I want to put the A over on the side with the alpha. So how would you move B to the right side? Divide both sides by B. And how would you move the A to the left? By both sides by A. So here the B's cancel, and you're left with the sine of alpha over A equals sine of beta over B. And that's pretty much what the law of sines is. There's one more fraction that you can put, and it follows the same pattern as the first two. And to figure that one out, we could draw the height from a different side and do this whole thing again. But what do you think this third fraction would be? Sine of what?
Yeah.
Sine of gamma divided by c. That is the law of sines. It has three parts to it. You never use all three at the same time. You use two parts at a time. So we may end up using the first two parts in a question. We might use the last two parts, or we might use the first part and the last part. But the idea is every time you do a law of sines problem, it's going to look like this. And what do you call something that has a fraction on each side with an equal sign? A proportion. Every problem is a proportion. And to solve a proportion, what's the name of the thing you do? You cross multiply. Yep. So every problem is cross multiplying. And that's pretty much it. You just have to fill in the proportion and then solve for whatever you're missing.
Wait, really? Why does this seem so much easier than what we've done?
Well, this is very numerical. The last thing we did is more a little bit more abstract because it has all the identities in it. I mean, what we did yesterday was still numerical, but it has all the identities, so that makes it harder.
How many questions will we be able to test tomorrow? Do you think, for quiz?
I'm not sure. Probably 3 of these.
Okay, so it's primarily going to be what we learned this week.
Yes.
Okay.
So the first thing we want to do is make a table. And you can draw a diagram if you need to. you're not really dealing with opposite, adjacent, and hypotenuse, so you don't have to visualize the position of things quite as much. We know alpha is 20, beta is 60, and A is 4. The only thing the diagram is helpful for is figuring out what kind of problem you have. Is it angle, side angle, angle, side, side? So let's label our diagram. I'm going to put A there. So where would 20 go? Bottom right. And I'm going to put beta. I'll put that one here. So that means the bottom is what side? B. That's C. That's gamma. Again, that is not drawn to scale. My diagrams are never drawn to scale.
Is there any benefit to recognizing off the bat that gamma is 100?
Well, we've got to write that down, so the sooner we can write that down, the better. But we're not, remember, we're going to try not to use that if we don't have to.
Okay.
And when we did right triangle trade, we never had to use anything that we found to find anything else. You're not quite going to be able to do that here. So what that means is if you mess up something, there is the possibility it messes up something else.
Oh, okay.
Now, gamma is 100, because they all have to add up to 180. And gamma has no effect on finding B. So if you get gamma wrong, you can still get B right. But if you get gamma wrong, you will get C. Because you have to use gamma to find C. Let's find B first. So you need to set up a proportion. What's going to go in each part of the proportion is 2 out of 3 of these fractions. The first fraction you always want to fill in is the row that has the full set of information. So which row here has everything in it?
A is alpha.
Yep, A and alpha. So fill in A and alpha into this first fraction. So sine of 20 over 4. Now the other side is what you don't know. We're trying to find B. So you're going to use this part right there. Sine beta over B. You're not using the third part yet. So we don't need that. So sine 60. And what goes in the bottom?
B.
B. And how do we solve that to get B by itself?
Multiply 60 by 4 and divide it by 6.
Yep, so it's going to be 4 sine 60 divided by sine 20. That's doing the cross multiplying all in one step. You'd have 4 sine 60 equals B sine 20, but then you'd have to divide by sine 20 to get B by itself. And we need to type that in. I think all the problems where you're solving triangles are going to be in degrees, so make sure you're in degrees. 4 sine 60. Also be careful with your parentheses. The way I typed it in is correct. Okay, 10.128. All right, now we've got 2 out of 3 of the sides. Can I do Pythagorean theorem to get this third one?
No.
Why?
Sorry.
This isn't a right triangle. It's not even that this is rounded. It's that this isn't even a right triangle, so this will come out wrong completely. Okay, so now we're going to find C, the same way we found B. I have 2 rows that have full information.
We're not going to want to use B.
But yeah, we don't want to use B. Stick with the row that had the full information that was given, because we know it's correct. All right, so how am I going to start this to find C? What's going to go on the left?
Sine divided by 4.
Sine of what? I can't. Sine of no alpha.
Are we not using the same word?
I hope we know alpha. I want to put a number.
Oh, 20 degrees.
20 degrees
Oh, yeah.
over
4.
4. And sine of what over what on the other side to find C.
100 over C.
Sine of 100 over C. Okay, so when we cross multiply, what is C going to equal? Not, you don't have to give me a decimal, just what times what divided by what.
4 sine of 100
Yep. So 4 sine 100 divided by sine 20. 4 sine 100 divided by sine 20. It gives me 11.518. Now you can't check it with Pythagorean theorem, but you can check that any two sides added together are bigger than the third. That should always be true in any triangle. Two sides added together have to be bigger than the third. And that does work here. That's it. That's a law of sine. So this would be set up with 3 blanks, and you get credit for each one that you get right. So this is really like 3 problems in terms of credit.
And there are going to be 3 of those.
Yeah, so it's like there'll be 9 answers for this section of the test.
How many questions from last week do you think there'll be? Those are going to be hard to remember.
They're just going to be incorporated to what we did this week. So like if you don't know the Pythagorean identities from what we did last week, and I ask you to solve a problem, you won't be able to solve it.
It's just science. Yeah.
Yeah, so you do have to know the identities from last week. That's pretty much the main thing to focus on. So 7.4, 7.5, 7.6, and 8.1 per one. All right, let's try this one. What kind of triangle is this one? In terms of like the 3 letters. This is ASA. So we would want to go back in the notes and see, is ASA a problem that works with law of cosines?
Law of cosine?
I'm sorry, law of sines.
Yeah.
Yes. Because that's a law of sines type problem, we can try to solve it. You may have a question that just says, you know, if this is not a law of sines problem, then just tell me why. It's not one of the 3 types, so you can't solve it with law of sines. But this one is solved. All right, Yankee table. ABC. Should I use it? Yeah, I usually put the angles on the right. Couldn't remember. Okay, and what do we know?
We know that alpha is 45.
Alpha is 45.
And then beta is 40.
Beta is 40.
And then gamma is 95.
Okay, so we'll come back. Let's fill that one in. Let's just put this last one in first.
Okay.
Okay, so whenever you're given 2 angles, the third one is pretty quick to find. And what did you say it was, Angel?
95.
95. Almost a right triangle, so if you use Pythagorean theorem, you would almost be right.
Wonderful.
You'd be wrong. So all of those have to add up to 180. Now, it's very important we get this right. Because why do you think getting this one right this time affects even more in the problem than it did last time? Yeah?
Because we have the sine C, so it's the opposite, like it's the angle for it, so you have the full set of numbers.
Right.
That's the only
Everything
one
else
we got.
This is the only row that has the full set of information.
We have to use that for both.
So we have to use it for both. So this time, if you get gamma wrong, then it's all wrong. It's not like last time, you could still get 1 right. All right, let's find it. What's going to be my proportion to find A.
Sine of 95 over 4.
Yeah, it doesn't matter what side you put the known on or the unknown. You just need sine 95 over 4 on one side of the other. Now I need the A part.
Sine 45 over 9.
Yep, sine 45 over A. Okay, cross multiply. And what is A going to be?
4 sine 45 over sine 95.
Perfect. And don't try to like do anything like if you think, oh, well, they're both divisible by 5, I can reduce it. You can't. You can't do anything like that. Okay, just type it all in just the way you see it. All right, so 4 sine 45 divided by sine 95. 2.839. Now, before we solve for B, what can you tell me about it? Just looking at what you've got.
It's gonna be smaller than 4.
Less than 1.2.
Well, it's definitely going to be less than 1.
4.
I can be a little bit more specific than that. It has to be less than A. Because it's the smallest angle, so it has to be the smallest side. But it can't be too small, because if you add these two together, they have to come out bigger than 4. So let's say B came out to 0.5. That's too small. 2.8 and 0.5 isn't bigger than 4. So you can kind of figure out, it's got to be between like 1.2, roughly, and 2.8. It's got to be somewhere in that area. Okay, let's see what we got. What's going to be my proportion to find B?
Sine over 95 over 4. Or sine of 95.
Sine 95 over 4. Yep.
And then sine 40 over b.
Equals sine 40 over B. So the nice thing is a lot of these calculations are pretty much the same. I'm just changing one number. So all I have to do is bring up the last calculation I typed in, and I can just change it to
Wait, what button did you do the 40? Did you get to do that?
second enter.
What did that do? Put in the same thing from before.
Yep.
That's very helpful.
Because all I want to do is change the 5 to a 0.
Yeah.
And do it again. 2.581. So that does fit what we said. It should have been between 1.2 and 2.8. And it was 2.581. Okay, so in both of these problems, we had to solve for 2 of the what? Sides. Had to figure out 2 of the sides, which means they gave you 2 of the angles, which really means they gave you all 3 angles because you can get the third one very, very quick. Now, the last type, last question, is a little different. Let's sketch it just to kind of. So we're going to put A and alpha, and put B on the bottom, beta, C, gamma. Okay, definitely that is side angle, because you know 2 of the sides and you know an angle, and the angle that you know is not the one between the sides. If it was, that would be SAS. That's a different kind of problem. So it's going to be a little bit different, because when we solve for what we're missing, we're going to have to solve for an angle. Both those angles. And what kind of trig do you use when you're trying to solve for an angle? Like if you had sine of x equals a half.
Inverse.
You need to use inverse trig. And remember, when you use inverse trig, it is possible you can get more than one answer. Now, an answer in quadrants 3 and 4 wouldn't make sense, because we're dealing with triangles. Triangles can only have a maximum of 180. So answers in quadrants 1 and 2 would make sense. And look where sine is. When you do sine, it's in quadrant 2. So it is possible when we start using inverse sine, which is the only inverse function we use in this section, you do get an answer in the second quadrant. So we need to check for that. Sometimes we do get a second answer. Sometimes we don't. If we get a second answer, then that means we're going to get two answers for everything we have to solve. So in this problem, you're finding c, beta, and gamma. You're either going to start to solve this, and it's going to work out just like the last two, and you're going to get one answer for beta, one answer for gamma, one answer for c. Or you're going to start to solve it, and you're going to realize there's two answers for beta, two answers for gamma, and two answers for c. Or we're going to start to solve it, and we're going to realize that with the information they gave us, it's impossible to make a triangle, which means there's no answer for beta, no answer for gamma, and no answer for c. But they all kind of stay together. It's either all of them have no answer, all of them have one, or all of them have two. You don't have to worry about what's not in the box. That was given. A, B, and alpha are done. We're never going to look for anything with those. Just what's in the box. Also, you really don't have any choice at what you want to do first here.
No,
Yeah.
Because when you're solving a law of sines problem, you need a full row in your table. That's why side, side, side doesn't work with law of sines. It's not a full row. You only have one row here that's full. So you have to use that. And if you have a row that's empty, well, that's useless. Because if you tried to use that, you'd be missing two things at the same time. So you need to use the row that's full and the row that's partially full. And there's only one option for that. So what are we going to find first?
Beta.
Yep. And this is different than what we did before because now we're solving for an A. Okay, what's going to go on the left side?
Sine 40 over 3.
Okay, so sine 40 over 3. And on the right?
Sine beta over 2.
Sine beta over 2. Okay. You really don't even need to cross multiply. Just multiply each side by 2. So you get 2 sine 40 over 3 equals sine beta. And now we want to get rid of sine. So how are we going to get rid of the sine that's on the right?
Inverse sine?
Yep. Going to take the inverse sine of everything on the left. And when you do it on the right, what happens?
Cancels out, just equals beta.
There we go. So now we need to type that in. There's nothing you can try to cancel. You got to type it in exactly the way it is. So inverse sine of 2 sine 40. Close your parenthesis. Because you're done with the argument to the sine function. You don't want to take the sine of 40 thirds. You want to take the sine of 40 and then divide by 3. And then close your parenthesis because you're done with the argument to the inverse sine function. Now, when I hit enter, one of two things is going to happen. It's either going to say error, which would then mean I either typed something in wrong or this is a no solution. Or it's going to give me a number, which then means there is a solution. Okay, so there is a solution to this problem. Now that I know there's at least one solution, I have to check for a second one. But I'm definitely going to write down 25.374. I'm going to put it higher in the box. Just in case there's a second answer, I'll just try to squeeze it in underneath it. And I would call it like beta 1 and beta 2. All right, which inverse trig function did we just use?
Inverse sine.
Inverse sine. Now, this value right here is positive. If you take 2 sine 40 over 3, that's a positive number. So we had sine equals a positive. We've got an answer in quadrant 1,
How do you know it's a
because it's between 0 and 90.
Oh, okay.
What would be the answer in the second quadrant?
154.
180 minus 25.
Right, the 180 minus 25.374. Now I'm going to write that off to the side. 154.626. So we know what the second answer would be. We have to figure out if it works.
No.
What?
Wait, it couldn't be.
Why?
Because it's just way too big,
Why?
right? Because a triangle has a max. Angles have to equal 180.
Okay,
And that would already equal more than 180.
right. We were given the 40. Okay.
Right.
The 40 is depth. If you think this is the other angle, then that adds up to 194. So it's too big to work with the 40. So in this case, there is no second answer, which means we can finish this like a normal problem. We don't have to look for a second answer for gamma or for C. Now, let's say the second answer came out to like 100. Well, then it would work because it would be small enough that you could fit it with what was given. But that's how you find the second answer. You just use that as your reference angle, subtract it from 180, and see if it fits with what you were given to start with. Now I can finally get a piece of information in the last row, so that row won't be useless. What can I figure out in the bottom row?
The angle.
Yeah, how would you get the angle?
Yeah, 40 plus beta. Subtracted from 180.
Yep. So I'm going to do 180 minus 65.374. And I know we are using things that we calculated to find other things. There's no way around it. So you have to do that. Yeah.
Why did you do 65? Because it's 25.
So yeah, 40 plus 25 gives me the 65, and then subtract from 180.
So you know how you said we have to like avoid things, finding answers to things we've calculated?
If you can.
Yeah. So in the instance where there is a second answer, we would then have to use we'd have to use the beta row to find the other answer, right?
We're going to go over the second answer case, but if there was a second answer, you'd basically have something like this. So then we'd have a gamma 2, we have a C1, we'd have a C2, and beta 2 would be 154.626. Gamma 2 would be 40.
Oh, whatever the other
Negative.
Yeah.
Yeah, in this case, 40 plus 154 adds up to too much.
Yeah.
So that's why there is no second answer in this one. So I'm not going to write those down. Now we can find C1. Well, it's actually just C using gamma. So which row would we want to use besides row C?
Calculate A. Right?
Yep, we use row A. And we're going to set it up just like the first one. Sine 40 over 3 equals, and what's going to go on the other side?
Over C.
Yep, over C. So now cross multiply, and that gives you your answer for C. So we're going to get 3 sine, and again, rounding to 3 decimal places is going to give us enough accuracy that you should be okay. So 3 sine 114.626 divided by sine 40. So let's say you got an answer here of like 4.5. I'm not gonna. That's way too far off. Okay, if you're rounding everything to 3 decimal places through the whole problem, you shouldn't be off by that much, especially in the tens place. All right. So if you got an answer of like 4.25 here, you know, I would mark that. Okay, 4.23. Yeah, that's fine. But if you got like 4.4, 4.5, that's too far off. Okay. So make sure you round at least to 3 decimal places. So 4.243. And you can always check. Any two sides added together should be bigger than the third, and the biggest angle should be with the biggest side. And that's the law of, well, the first part of the law of science. Any questions on that? Alright, so we're going to put up the homework. So it's in the book 5 through 8, 10 and 16. And then these two questions I just made up, those top things, those are alphas. And then beta, and then C. Off to the side, I will put the topics that are going to be on the test. Might be able to get that done before you leave.
The top ones are Hager.
I like those people in the chat. We're winning.